For those of us who want to help heal our broken biospheric metabolism, to heal the rift using nexus thinking, the first step is to reconceive the drain. If the tube stuff goes down took all the materials to another part of the system, which put them back into service for the production of food and energy and clean water, then going down the drain would be part of a process to celebrate going back into service. And what is ironic is that the microbes contained within our so-called wastes actually add value to what goes down the drain. They improve the materials and capitalize things, accumulating wealth, so to speak. So a trip down the drain, when reconnected to the input side of the metabolism, is a journey of capitalization, of wealth increase. Once we're in a cradle-to-cradle system, every flush becomes the winning royal flush. I was meditating on this topic when giving a keynote address to the Arizona Science Teachers Association that I was able to give inside the Biosphere 2 in Arizona in June 2017. Listening to the other scientists and speakers and exploring the biosphere again after 20 years, because I was inside it for the first time just before they sealed it as one of NASA's Challenger 7 space science teachers back in the early 90s. I had many thoughts about the topic of sanitation and sewers, of drains and tubes. At my presentation, I showed a music video my students and I had created in 1993 to show what we were doing at the inner city high school that I taught in South LA, to apply what we were learning from the Biosphere 2 experiment to our curriculum. The lyrics to the song that the students sang expresses how I feel about the future of sustainability. The lyrics were, "We don't have a thing to fear, we're living in a biosphere of life. We could last for years and years recycling the materials of life, improving our society." There's a link for the old music video on YouTube that I've posted that you can watch. And I told the teachers assembled at that weekend that what I didn't have a good sense for back then in 1993 was how easy it really is to bring the biospheric consciousness to our own homes and communities. And that's because while I'd read stuff and visited places, I myself hadn't tried to actually live in a closed-loop system back then. And I didn't know, for example, how easy it was to build solar hot water systems or install photovoltaic electric and wind power systems, or most importantly, to turn human, animal, and food wastes and other organic waste into clean fuel and fertilizer. But now I do. And the funny thing is, the public was told that Biosphere 2 had failed, when really the main takeaways they should have gotten was that we were closer than ever to figuring out how to live in a closed-loop system, but that some issues relevant only to recreating the system on another planet made things difficult. For example, there was the issue that the cement in the biosphere was still curing, so one must really wait several years longer before sealing a biosphere so the oxygen doesn't get used up during the drying process. And that contrary to what we learn in middle school, plants don't just give us oxygen in exchange for the CO2 that we emit. They also consume the very oxygen they put out. So we must make sure carbon is sequestered as plants grow so their decay doesn't use up all the net oxygen they produced. We learned, for example, from Biosphere 2 that most pollinators need UV light to navigate, and that bees are critical to feed ourselves, or humans must spend the bulk of their time on their hands and knees hand-pollinating the food crops that we depend on. And then the energetics of food production don't work out that well. But apart from these critical lessons and the difficulties people experience socially when forced to live together in isolation for 2 years, what we learned from the Biosphere 2 experiment was actually very hopeful. We actually learned that most of us, when subsidized and supported by Biosphere 1, our Mother Earth, really can meet all of our needs, even at our current population density, by simply and effectively recycling the materials of life in as local a way as possible. So what is the future of sustainability and solar energy? I believe that the future lies in home and community biospherics. And by this I mean that making the change really does start at home and in the neighborhood, your neighborhood, which must become the centers of the sustainability movement. We need to, and some of us are, create local biospheres, most of them not materially enclosed, but conceptually as closed loop as possible. We can call on the tradition of victory gardens, used during times of war to get through tough times, but with what we now know about small-scale biodigestion to eliminate the problems associated with organic wastes and create fertilizer for vertical farming, urban farming, rooftop gardening, and hydroponics, aquaponics, and aeroponics. And what we now know about micro-livestock and increased biodiversity in our diets, including insects as a micro-livestock. Well, there's no reason at all that families, neighborhoods, even city blocks can't take care of themselves in a meaningful way. Using home photovoltaic and solar thermal and wind and biogas technologies and community gasification and pyrolysis and plastic to oil technologies, actually all domestic energy needs can be easily met, as anybody who has lived off-grid, as I do in my RV, can attest. Most businesses can similarly provide for themselves. This is the level most meaningful to the majority of citizens, and the first thing to work on as society restructures itself so nobody has to suffer during the transition to a sustainable economy. The question that needs to be asked is, what can you do at home to close the loop, to make your community as autonomous as possible? What can you do with what you've got? Industrial ecology is the way forward for our manufacturing and processing centers, where one industry's outputs furnish the inputs, materials, chemicals, heat, cold, energy for another. In transportation energy, it's really easier than we've led people to believe. Besides electric vehicles and self-driving cars and trucks and buses and renewable energy-powered roadways, which generate much of the energy the vehicles consume, we have, for example, DME, dimethyl ether, for internal combustion engines that is inadequately explored, but which Volvo is dedicated to producing. See their great video in the link that I provide. Have you ever heard of DME? Probably not. And that's part of the crime. So many things, so many solutions out there that most of us have never been introduced to, that are out of our curriculum in our schools, that are not in the public purview. Look up DME, dimethyl ether. It can be made out of almost anything. There's so many positive things going on in the world that we must get away from the divisive language and inaccurate descriptions of the technologies and concepts that underlie sustainability that are scaring many people away from even trying. One thing that we believe in my NGO, Solar Cities, is that we must do a much better job at scientific literacy, particularly, for example, teaching our children and citizens to recognize that the vast majority of the energy they use is actually some form of solar energy, that is, stellar fusion energy. And we must teach them that fossil fuels like coal and oil are stored solar energy, but they're a very dirty form of solar energy the way they're currently used. And we need to teach them that wind and water, hydropower, and wave power are merely the effects of solar energy on fluids, that biomass is stored solar energy, and most importantly, that food waste and toilet waste and all organic waste from cities, from restaurants and farms and fields and forests, your backyard, are forms of stored solar energy that can be easily transformed into clean energy and new food, which is another form of stored solar energy. Food is stored solar energy. And that this can be done by almost anybody. Rather than speaking as though going solar was something new or exotic or expensive, they simply have to decide which forms of solar energy have more benefits than costs, at which times, and for which applications. We have to help citizens understand how to do full cost accounting of every form of solar energy we use, internalizing health and social costs and eliminating negative externalities. We must teach our children to recognize that the other forms of energy available to us are either gravitational, rotational energy, for example, tidal power, or nuclear decay energy, for example, geothermal, ground source heat, and atomic power. Society then has to make decisions about the location of the fusion and fission sources that power our world. That is, when and where should they use the effects of the fusion reactor 93 million miles away, called the sun, and use the effects of the fission reactor 6,000 kilometers below our feet, the heat of the Earth's core, or when to try to safely recreate these reactors on the surface of the Earth. When the public begins to see the similarities and differences between energy sources and their choices, we can have a more informed debate about which ones to use, how to use them, when to use them, and what to invest in order to ensure their efficiency and safety. We must teach our children and each other to see the embedded energy and water and labor and value in every object, to look at things with a kind of X-ray vision that tells us the history of the material, how much energy and labor and investment went into producing and moving it and setting it up, how much is still there of value when it's thrown away, implying it should never be thrown away because there is no away, a key tenet of biospherics. We must teach our children that there is no such thing as waste, that what they see in the garbage bin and currently in landfill is raw material, polymers and valuable and precious metals and fibers and chemicals that are now easier to access than they would be coming from virgin sources of material, coming from so-called nature. Much of the problem we face boils down to an improper conceptualization of what materials are and an irresponsible devaluing language used to describe things. By using sloppy language and bad conceptualization and gross oversimplifications of science, we end up dividing ourselves into warring camps and rival teams. Assumptions are made that aren't helpful and can be harmful.